Hi, my name is Teodora Sandra Buda, and I'm a researcher at Khwaja Health. Today I'll present to you our work on how outliers in smartphone sensor data reveal outliers in daily happiness. I'll go first through a background into smartphone-based modeling of emotional states. Second, I'll give an overview of the challenges in the area. Third, I'll present to you our approach based on outliers for modeling daily happiness. And fourth, I'll give you an overview of the studies that we ran and our results in two different settings. This work started from inspiration that if you're having a bad day, your phone is probably having a bad day as well. Imagine that you're exhibiting irregular behavior. This will most likely be captured through irregular smartphone sensors data. So first, the problem. Here we distinguish between user traits modeling and states modeling. Traits represent stable statements about an individual. They're long-lasting and internally caused, whereas states are temporary indicators of the status of an individual. They are brief and typically caused by external circumstances. Naturally, the features that are used to model these two very different target features are different. First, to target traits, these features quantify longer-term patterns, whereas to target states, they are typically extracted as an aggregate of smartphone sensors readings for shorter periods of time, such as daily. The problem with that is that mostly these are descriptive statistics of absolute sensor readings, and they are with regards to the population. Thus, the model are ill-equipped to capture individual differences. More on the challenges. First, we start with sensor sensitivity. Here, we took data from different smartphone devices, locked in a room for 5 days, and without any interaction with these phones. And as you can see, the light sensor and accelerometer show very, very different readings depending on the device type. This, of course, can influence the machine learning model. Second, individual routine differences. Here we show the mean number of steps, the total amount of noise, and the time on phone unlock for two very different individuals that belong to the first quartile or the fourth quartile of the corresponding distribution. As you can see, people exhibit very different behaviors, and these are captured from smartphone sensors data in very different ways. Third, subjectivity and ground truth. If in this case, we are looking at happiness level as an example of our approach, but as we can see, these figures illustrate individual differences in the range of values used to rate subjective happiness levels, which may be mislabeled by applying population device reference points. So how is our approach? Well, first, we propose to aggregate the sensor features based on each individual's distribution into encodings that are either lower outlier, regular, or upper outlier. Third, the target feature is also encoded to outliers based on, again, each individual's distribution. And then finally, a model is trained based on the outlier features and based on the outlier target feature. For our study, we collected data from two different cohorts. The first is the diverse, that included 222 users from 5 different countries: Chile, Colombia, Peru, Spain, and UK. And the study was run from February to August 2018. The second cohort is the university cohort. It included 481 participants. It ran from January to March 2019 from a major UK university. The participants were asked to use the application for a period of 2 to 3 weeks. Then it was collected both from iOS and Android data, Android devices, and the app was collecting phone usage logs and sensor data. It was prompting users 5 times during the day through EMAs and 1 daily happiness question: how happy did you feel that day? We use this as target feature. As you can see, we applied various different filtering criteria. First, most of our data was from Android users, so we only used Android users in this evaluation. Second, we removed days with less than 70% of all features, similar to other studies that were and other analyses that were done in the field. And second, we used only users that provided less than 7 days. We discarded users that provided less than 7 days of daily well-being and smartphone data. Though the study presented in this paper did not push the accuracy levels, our results demonstrate that the outlier-based approach can yield improvements in capturing relevant signals and emotional states. When tested in various different configurations, the newly proposed method outperformed the traditional user state modeling methods. Interestingly, extracting percentiles that carry more information than outliers only, as it precisely quantifies how unusual or usual an observation is for a specific individual, did not bring additional improvements in accuracy as compared to outliers. Here we show AUC, F-score, kappa, and accuracy, and we mainly optimized for the AUC score, which we can see that it shows up to 14% improvement. Replicability is a crisis in multiple domains, and in particular in machine learning-based user models. Evaluating the same model in different experiments and under different conditions is essential to advance models towards real-world applications. So here we show how we trained on the diverse cohort and we tested on the university cohort, and still the outlier-based approach maintains the accuracy. So thank you very much for your attention, and goodbye.